questions? I'm sure there'll be some.
Michelle and Brian, thank you very much for your presentation. I see that Julian has a question.
Brian, I was very interested in that what you actually had was a contaminated site due to the operator handling the target material. Do you now have a protocol that says that the target material must be handled by somebody who then leaves the premises?
Oh, absolutely. Plus disposable clothing, etc., over clothing. We're following the nuclear industry, you know, put another layer of material on, put another, because we don't want the artifact due to the operator. We want the true engineering performance of the hardware, other than the fact the operator has to be present to do the operation.
Right. Well, one of the things that we've done in the past is to get the vendor to nominate somebody who handles the target material, and they're then sent home for the day and told not to come back again until the testing is over.
And whatever you do, don't dispense the material in the building. You're going to do the testing.
Well, absolutely right. You know, there have been example after example where the actual transfer of the target material, which we try to do during the background testing, has shown that you get nanogram levels just moving a naproxen bottle through an airlock. You get 14 nanograms.
Easily, yeah.
Right.
Yeah.
So, I was just surprised you didn't have a protocol in place.
This was our first time around. We learned the hard way. I wanted to show it because it is a lesson in stupidity. Informed knowledge, if you will.
Right.
And the fact that we had such an array of data around the hardware made us challenge what would have been the ISP good practices way of doing it and say, this doesn't make sense. Why are we getting this?
Right.
And it turned out to be an artifact that we could trace because of the volume of data that we had.
We've just had the same picture. In fact, Safebridge were the people doing the IH. The actual protocol was written by the client, and the guy who wrote the protocol handled the target material and stayed in the area, and we had the same pattern.
Yeah.
Okay.
And in fact, anybody moving into and out of the enclosure can create artifact too, like the industrial hygienist who's putting on booties, but he puts the booties on before he enters the barrier. You know, where do you draw that line? Particles do cross over white lines, contrary to what everybody believes in our industry. They're not informed particles. They don't read the books or follow the procedures. They do cross over. And that's why we chase ghosts so much when we're doing troubleshooting and analysis of the data.
Could I just do a quick supplement? Did you ever run that test using the standard spade pack with the IOM or the other cassettes? And did you look at the difference in data? How critical was the difference in data?
We did not replicate every location, but the work that was done by the hygienist, the room area samples and the personal were 37 millimeter standard cassettes. What we used were, for the array around the glove box, the engineering data where we could catch settling dust and so forth, which should be worst case, were the vertical cassettes. So no, we've never run the same study with the same cassettes. Plus, you'd have to run the two cassettes side by side in the environment. And my concern there would be, now you're starting to vacuum that volume of space that you're trying to sample because you've increased the sampling rate more. The number of controls that you have to exercise, you have to bear a lot of things in mind. You don't want to distort the data by your activities.
Right. You've got a lot of trouble to create a sort of a model environment to try and take out all the sort of variations with airflows and so on. But you've got two bodies in there. Normally that would be operated by a single operator. So you picked up a convection current from a single operator, but you put an IH guy behind him who's going to create convection currents in their own right. Why didn't you put him outside?
In the second study and third study we did. The first study was one where he was in there trying to observe why he was having problems with the filter dryer. But yeah, we excluded him in the second and third one. Once he'd done his setup and calibration, he left. The operator did the process and then came out. Left the room quiet for 2 hours.
The data you've got, obviously, you've done, as I say, a very model sampling protocol. What do you think that data actually means in terms of operator exposure? I mean, if you look at the classic occupational hygiene or industrial hygiene approach, they say background samples are very interesting, maybe give you an idea of control, but one we're interested in is the lapel monitor because that's what the guy is breathing. So Obviously, you've made some comments about the relevance of that. What do you think? I mean, the data you've got seems to be emission monitoring, not exposure monitoring.
That's the engineering aspect. It is the emission. What is the emission factor from the hardware due to the hardware design? The other one, the artifact, we've done enough monitoring of areas, and we've been testing glove boxes since 1994, okay? Lots of volumes of data under controlled situations. We found we cannot, most of the time, explain what's happening to the operator. They will go into an area for a break while you're having a rest. They'll come back and they've been contaminated by another operator in the break area who's working with a similar product. So what it means, and let me take it further, you said this as a model. It is. You couldn't do a containment factor if you had ventilation in that room. Because the stuff doesn't just stay there. You're disturbing the flow of the... You can develop an isolation factor in a clean room from the glove box, etc., but you can't determine a containment factor. You can only determine an isolation factor for the whole matrix, including ventilation and people flow and everything else. We did an ideal situation because of the confined space, which is probably the best FAT you could do. But when you get into the real world, now you have to deal with the ventilation dilution that will change all of your data. Okay, it is not going to behave the same way as just the hardware would by itself.
So you only apply this approach for an FAT?
Yes.
You wouldn't do it on the plant?
I could if I wanted to build an enclosure, yes. But normally you would not do that. No. The real world is different, and it has a lot more dynamics. We were interested in how can we define the performance of a piece of hardware just by itself, just being run through the unit operations by a trained operator.
Am I right that if you make an enclosure with thin film, whatever, you could do this testing in a room with an HVAC system?
Oh, absolutely, yeah. In fact, the whole premise of this is you have enough statistical robustness in your data that you can go back a year from now and test the same piece of equipment under the same set of conditions as long as you build the enclosure and see if the maintenance operations, the wear and tear, you have deteriorated the performance. Or do your operators need retraining?
Okay.
One question about the charging valve you use. You take a charge point valve from PSL. Have you a suction for charging the dryer, and have you measured the process of loading the dryer with this on this way?
What we did in this particular case is we started off with the dryer having been dried. So we put a bag of dispensed material into the manway of the dryer. So we didn't actually address that issue. You could certainly do comparable testing with the transfer system.
Okay.
And we have done testing but in a facility the same way. I mean, this is how we did it with the Dover project back in 1996. We had the array around the hardware, and then we had the array in the room. And it was interesting because the array around the hardware had less issues because overhead there was the top of the filter dryer where we were charging. It was coming down through the annulus around the filter dryer. I mean, you've got to look for all of these artifacts. What is the engineering performance and what is the other contribution? With enough sampling, you do it. If you do it, a sampling study probably costs you about $18,000 to set up, with excluding the material for testing. Just the time, the people, the lab support, and so forth. So you really want to get as much value out of it as you can. For me, taking more samples during a single study is the cheapest way to do anything, because the lab can put them on an automatic carousel and it doesn't take any more time than maybe a few more desorptions of the filter to get a whole lot more data. But be sure that the study is well designed and they follow the protocol, because look what's at risk. A lot of investment.